This is the Indonesian archipelago, specifically the volcanic islands of Komodo and Rinca. It is a volcanic, semi-arid landscape where temperatures frequently peak at 95 degrees, and basic resources like water are tightly guarded commodities. Yet in this uncompromising environment, one creature has secured its place as the absolute apex predator. The Komodo dragon is uniquely adapted to thrive within this specific, sun-baked ecosystem. Beneath their scales, these lizards carry thousands of tiny bones called osteoderms. These interlock across the animal's body to form a layer of natural chainmail, acting as a built-in suit of armor. Standard reptilian biology is defined by a low metabolism and limited stamina. Yet these lizards routinely kill prey 10 to 20 times their own size, overcoming cold-blooded constraints to take down massive water buffalo. For much of the 20th century, the scientific consensus was that these were primitive scavengers with exceptionally dirty mouths. The theory held that their saliva was so saturated with rotting meat and bacteria that a single bite would cause fatal sepsis in a matter of days. That changed in 2009. Researchers analyzed the dragon's skull and debunked the bacteria myth, revealing the lizard to be a highly evolved, calculated assassin. The Komodo dragon doesn't rely on blunt force or accidental infections to survive. Its entire anatomy has been refined over millions of years, sharpening every sense and physical trait into a specialized system for predation. To navigate this environment, the dragon relies on its deeply forked tongue. By constantly flicking it into the air, the massive lizard captures invisible chemical molecules floating on the wind. Those particles are then pulled back into the mouth and delivered to the Jacobson's organ, a specialized sensory structure in the palate that performs a complex chemical analysis of the air. This sensory array allows a dragon to track a living deer or a decaying carcass from up to 6 miles away. The deeply forked tongue can even detect a chemical gradient, helping the dragon determine exactly which direction the smell is coming from. Once a target is identified, the dragon relies on extreme patience. It can remain perfectly motionless along a game trail for up to 18 hours, positioning itself downwind to ensure its own scent doesn't alert the approaching prey. This sensory network maps and controls every movement across the island. By the time a dragon begins its wait, the shimmering heat of the savanna has been transformed into a precisely monitored hunting ground. When an animal finally wanders into the strike zone, the dragon launches into a sudden sprint that can reach 20 kilometers per hour. Unlike sluggish reptiles, the Komodo's heart delivers oxygen with mammalian-like efficiency, fueling an explosive charge that defies cold-blooded limitations. It connects with 60 iron-coated, backward-curving teeth, slicing through thick hide instantly before letting go. That single bite delivers a lethal chemical payload. Researcher Brian Fry discovered that hidden in the dragon's lower jaw are functional venom glands that pump toxins directly into the wound. The venom triggers a catastrophic drop in the animal's blood pressure and prevents its blood from clotting. This ensures that even a minor wound will continue to bleed out, preventing the body from healing itself. While the panicked prey may initially escape, it quickly succumbs to shock and massive blood loss. The dragon doesn't chase it. It simply uses its tongue to follow the scent trail until the animal eventually collapses. The Komodo's true weapon is biological inevitability. Once the toxic venom enters the bloodstream, the prey's own circulatory system quickly becomes the inescapable mechanism of its death. When the prey finally falls, the scent of the blood loss draws in competing dragons from across the island to the site of the kill. The feeding process is brutal. Dragons will often ram a carcass against a tree to force massive chunks of meat and bone down their throats, allowing them to consume up to 80% of their total body weight in one sitting. This environment is so competitive that cannibalism is common. To survive, juveniles must live in the trees out of reach of the adults, or roll in feces to mask their scent and make themselves unappetizing. This hierarchy is the result of an evolutionary lineage that stretches back 4 million years to Pleistocene Australia. As they migrated into Indonesia, geographic isolation and a lack of competitors resulted in island gigantism. They became the undisputed rulers of these islands, eventually overlapping with ancient human relatives. 3-foot-tall human relatives known as hobbits also lived here. Analysis of ancient bones suggests they didn't hunt big game themselves. Instead, they likely survived by scavenging the leftovers of dragon kills. For millions of years, the dragon has remained so dominant that even our own ancestors were reduced to picking up their scraps to survive. Isolated on fragmented islands, the dragon evolved one final survival mechanism, the ability to reproduce without a mate. Called parthenogenesis, an unfertilized egg autonomously doubles its chromosomes. A single female can start a population alone. Because of their ZW chromosome system, this doubling produces exclusively male offspring. They can then mate with the original female, creating genetic diversity for a new colony. Today, this ancient species exists at the intersection of a mythic past and an uncertain future. We now share this space, bringing the world's largest lizard into direct contact with the modern world. The dragon is now classified as endangered. They face the only true existential threats to their 4-million-year reign: human-driven habitat loss and the shifting temperatures of climate change. The Komodo dragon is an evolutionary masterpiece, but its future survival now depends entirely on the protection of the fragile, isolated ecosystem it has ruled for millions of years.